students, I hope everyone is fine. Today I am going to start the mole concept lesson 5B. 5A I have already completed with you, and the PDF in which the exercise question answers of 5A as well as the exercise questions of 5B also I have already given you in the PDF form. The full question answers with the solution has been given, so please go through them. So today I am going to solve few of the numericals of 5B. So let's start. The first three questions are all numeric or all theoretical questions. So I have given the answers in the PDF. Please go through them. Let us start with the question number 4. I'm going to solve 1, 2 for you so that rest of the you can solve. Okay, let's start. So, question 4. Okay, so the first two I am solving for you. That is the first one is the ammonium chloroplatinate. Sometimes in the question papers you will get the atomic masses of them, but few of the atomic masses you have to remember. Okay, students? NH4 whole 2 PTCl6. Let's start. The atomic masses of each, that is the nitrogen is 14, then platinum is 195, then chlorine 35.5, then hydrogen is 1. Okay, so let us do. First of all, put the values of them. NH4 whole 2 PTCl6. That means this is 2 times, so we can write 2. Then NH4, NH means 14. All will be added up. Plus this 4 times, that means 1 into 4. Close the bracket. 2 already I have written. Platinum is 195 plus 6 times of 35.5. 35.5 into 6. This is the calculation. Okay. Now just add up all. 2, 14 plus 4 plus 195 plus this one comes out as 213. Then it becomes 14, 4, 18 to 36 plus 195 plus 213. So total comes out as, you will just add up, 444 grams. You can write that whenever molecular weight expressed in gram, it is known as, it is in the express of grams also we can write. Now next one we will see chlorine. I have already done one, so I am taking the ammonium sulfate. Okay, so let's see. Ammonium sulfate. First write the formula properly. Okay, now here N, H, only O and S, rest are known from here. So S and O. How much? 16, and this one 32. Okay, now let us see. NH4 whole 2, that is 2 times of this, so we can write 2 into 14 plus 4 into 1 4 plus 32 plus 16 into 4 64. Okay, you will calculate it. Next is just This one 18, 18 into 2, 36 plus 32 plus 64. Okay, so the total comes out as 132. You can write gram also, AMU also. Okay, AMU. Clear? Like this here also you can write as a AMU because all the units have been given in this. So you write as a. If you leave it like that also, then also no problem is there. Okay. So let us go to the next, number 5. Number 5 also many are there. So I am going to solve 1, 2 for you. Question number 5. Find the number of molecules in 73 grams of ACl. So first we have to find out the molecular mass of ACl. Okay, ACl. We know that 1 mole of ACl is what? How much? Cl is 35.5 and H is 1. So total becomes 36.5. So we are writing mass of 1 mole of ACl is how much? 36.5. Okay. Now we know that 1 mole of anything contains, what is the Avogadro number? It is told how many molecules. That means we have to find out the Avogadro's number. So we know 1 mole of anything contains 6.023 into 10 to the power 23. So let us write 1 mole this much. That means we know that 1 mole of ACl contains how much? 6.022 into 10 to the power 23 molecules. Clear? Now this is the, we know that this much it contains. Now we want the molecules, so we have to take it this side. So 36.5 grams, 36.5 grams of ACl contains how much? 6.022 into 10 to the power 23 molecules. Clear? So 1 contains just unitary form. Unitary method in the mathematics you do. The same way here also you have to do. Or you know the formula also of this. By 36.5. And how much is given? How many grams? 73 grams. So 73 grams of ACl will contain how much? 6.022 into 10 to the power 23 by 36.5 into 73. You just make it calculated and the answer will come out as 12 into 10 to the power 23. Or if you want to change it as in a fraction, if you want to keep 12 point something, it is coming. So if you want to keep it as a fraction, then 6 into 2, that means it will become 1.2 and this will be changed it to 1 minus, it will do 24. Anything you can do. Okay. Now the next sum we will do number D1. Number of moles in 10 grams of CaCO3. Now it is asking number of moles, not molecules. So let us find out number of moles in 10 grams of CaCO3. So first of all we have to take out the molecular mass of CaCO3. And we know that 1 mole, that is the 1 mole it contains. So 1 mole of CaCO3 is how much? calcium is 40, carbon is 12, oxygen is 16. So we will put the values. Ca 40 plus 12 plus 16 into 3. So how much it comes out? You will do the calculation. You will get 100 grams of your AMU, whatever you write. So this is the 1 mole contains. So 1 mole contains this much. But the question is given in reverse way. So you will write 100 grams of CaCO3 contains 1 mole. So 100 grams of CaCO3 contains how much? 1 mole. So 1 contain 1 by 100. And what is given in the question? 10 grams. So what is the 10 gram will contain? One by 100 into 10. So 1 by 10. So 1 by 10 is equal to 0.1. This time we are finding what? Mole. This is the answer. Got it? So in this way we will proceed. Now coming to the next one. Number 6 is telling what? Which of the following would weighs most? You have to take out all and then you have to see which one is the highest. So 1 mole of H2O, 1 mole of CO2, 1 mole of NH3 and 1 mole of CO. So let us see. First it is told 1 mole of H2O. So number A is telling 1 mole of H2O. So 1 mole of H2O means 2 plus 16, that means 18 AMU, or you can say gram. Okay, now we are taking out the moles. So similarly with the CO2, next is the number B is the 1 mole of CO2. C is 12 and 16, 12 plus, this one you can write it, 2 plus 16. And this one, 12 plus 16 into 2. So comes out how much? 16 to the 32, 32 plus 12 is 44. Number C is what? 1 mole of NH3. So 1 mole of NH3, that means 14 plus 3, 3 into 1, that means 17. In this way you can find out. Okay, number 4, 1 mole of CO. So I am writing here 1 mole of carbon monoxide, that is, so how much? C is 12 and that is 16. So 12 plus 16 is equal to how much? 8 and 2, 28. Clear? So in this way we find out all. Which one is highest here? One is 18, 17, 28, 44. So this one is the highest. Clear? So we can say that 1 mole of CO2 weighs the most. Okay, so lastly we will write therefore 1 mole of CO2 weighs the most. Clear? Now coming to the next. Number 8 I am doing. Calculate the number of particles in 0.1 mole of any substance. Now mole is given, particles you have to find out. More or less same. Now you have to put the formulas also and find out the answer. Number of particles is equal to what? Mole into Avogadro number. This is the formula, okay? Mole into Avogadro number. I am writing in short. You will write in a copy in a complete way. So, what is the mole given here? 0.1. And what is the Avogadro number? You know, 6.023 into 10 to the power 22. Now write 0.1 into 6.022 into 10 to the power 23. So you calculate this one. It is coming out. Just one less it will be. Okay. So answer is 6.022 into 10 to the power how much? 22. Okay. So in this way we got the number of particles. Just putting the values and get the answer. Okay. Or you can do with the unitary method also, like mathematics what you do. Now we see that molecules in 1 kg of calcium chloride. So let us see. Number of molecules is equal to Avogadro number into mole. And mole we know that again what? That weight in gram by molecular mass. So I can write like this. Avogadro number into mole. And we know that what is mole? Mole is this part is equal to how much? Weight in grams by molecular mass. That is the mole. Into Avogadro number is already there. Now put the values. What is the value given there? (6.022) into 10 to the power 23 into, first of all you have to take out the CaCl2. Okay, without that you will not be able to proceed. So CaCl2, that means, so you take out this, it will come out as a 111. It is coming 71. Okay, and 71 plus 40, it is becoming 111. Now we know that 1 kg means weight in grams of calcium chloride, and weight in grams is how much it is given. First of all you write this one, 6.022 into 10 to the power 23 into weight in grams is given how much? 1 kg. 1 kg we have to make it in the gram, because you know moles and everything are taken as a gram. So 1 kg is equal to 1000 gram divided by molecular mass. Molecular mass we have taken out 111. So now do the calculation. The answer will come out as 5.42 into 10 to the power 24. Students, you can do this calculation and do. Okay. Now we will see the question number 9. Now question number 9, number A is telling how many grams of aluminium are present in 0.2 moles of it. Now one straight formula is also there. You can apply, or unitary method also you can apply. So what is the straight formula is there? Weight in grams is equal to how much? Mole into molecular mass. So we can do that also. Otherwise unitary method also you can do. I am showing you with the unitary method. First we will write the atomic mass of aluminium. How much? 27. Okay. Atomic mass of aluminium is 27. Unit is given in grams, everything. So it will be also gram. Okay. Now that 27 grams is how much? Is equal to 1 mole. So 1 mole contains how much? 27 grams of aluminum. Clear? So how much it is given? 0.2. That means 0.2 mole contains 27 into 0. Okay. Now you calculate it and get it done. The answer comes out as 5.4 gram. This one you can write like this also. Okay. So it will be easy for you to calculate 5 grams of. So see students, the direct multiplication, mole into molecular mass. This formula also is there for finding out the grams, weight in grams. Number D I am doing. The rest you practice. So CO2 it is telling, how much it is telling? CO2? CO2 is present in 0.1 moles of it. So CO2 present in 0.1 mole of it. So we will say again the same thing. CO2 is how much? CO2 is the molecular mass is how much? Molecular mass is CO2 is a compound. So molecular mass of CO2 is 12 plus 32, that is 44 grams. Okay. Now we know that 1 mole contains 44 gram. And how much given here? 0.1. So 0.1 will contain how much? Okay. So in this way we will find out. So 1 mole contain CO2 how much? 44 grams. So 0.1 mole will contain how much? 44 into 0.1. So is equal to 4.4 grams. Clear? So in this way I have solved 2 for you. Rest of the numericals you solve by yourself. Try to find out. Otherwise all the solution has been given to you. First you try first, then you match it with the answers. This will give you the good practice. Number 11 is, let us see what is the question. Calculate the number of moles of CO2 which contain 8 grams of O2. It is a little bit twisted. So let us see. In one molecule of O2 contains how much? O2 is equal to O2. That means 16 into 2. That is 32. Clear? Now, this 32 grams is in 1 mole. So, 32 grams of O2 is in 1 mole. Okay? Now, 1 will be how much? 1 by 32. Clear? Next is how much given in the question? 8 grams. 8 grams of O2 will be how much? 1 by 32 into 8. So is equal to 1 by 4 or 0.25. Clear? Moles have been taken out. Methane in 0.8 gram of methane. So let us see. Mass of 1 mole of methane means how much? 1 mole of methane is equal to how much? 12 plus 4. 12 plus H4, 4. So 60. Clear? Now what it says now? and we know that now it is told how much number of moles. You can find in the unitary method also that 16 contains 1 mole. So 1 contains this much. So what will contain in the 0.8? So you will write like that. That also will give the answer. But or you can apply the formula also. We know that the formula is number of moles is equal to weight in grams divided by molecular mass. Answer will be same, but the two methods I am showing you. Okay, so weight in grams means how much? How much is given? Weight is given 0.80. Okay, so 0.8 by molecular mass. Molecular mass is 60. Clear? So you just calculate it and it comes out as a 0.05 grams. Clear? So in this way, sorry, you are taking out moles. Sorry, it should be moles. How much moles is there? Number of moles we have taken out, no? So it will come out the number of moles. So first, always remember we have to take out the molecular mass or atomic mass, whatever that has been given to you, and it contains 1 mole, and we know number of moles is equal to weight in grams by molecular mass, so we put the value and get the answer. So I have shown you number A with the unitary method, number B with the formula method. So both are the same answer. Both are correct. Okay. Now coming to the number 12. Okay. Number 12, let me read. Calculate the actual mass of, here you will get one formula, that's why I am giving you this one. So find out the actual mass of an atom of oxygen, an atom of hydrogen, a molecule of ammonia, atom of silver, molecule of oxygen, 0.2 gram atom of calcium. So if I take out one or two, others you can find out. Let us see. Number 12. So number 12 is told calculate the actual mass. So actual mass is what? Molecular mass by Avogadro number. So remember this formula. Actual mass is equal to molecular mass by Avogadro's number. So put the values now. Now it becomes easy for you. I am doing the molecule and number C and number F I am doing. Rest are the very easy. Atoms of that means they are containing only the direct atomic number mass you will give of them, and you will find out the answers of them. So number C will be 1 molecule of ammonia is equal to is equal to 14 plus 3, that is 17 grams. Clear? Now actual mass is equal to molecular mass by Avogadro number. You put the value now. Now actual mass is equal to 17 divided by 6.022 into 10 to the power 23. So how much it is coming out? You just see 2.8 into 10 to the power 23. Okay, 10 to the power it will be minus 23. Okay, because it will go up. Okay, so this is what. So for molecule I have taken out. Now for the 1 gram atom of calcium. So 1 gram atom of calcium contains how much? You know the molecular mass when expressed in gram is the gram atom or gram molecule. So it is the atom, it is a element. So 1 gram atom of calcium contains, calcium is 40, so 40 gram. 1 gram contains this much, then 0.25. That means you divide the 0.25 as a 1/4. Yes or no? So it will contain how much? 0.2 gram of calcium will contain 40 divided by 40 into 0.25. So that means 25 by 100. 1 by 4 into 40, that means 10 grams. So 0.25 contains 10 grams. That is the clear? Now students, we will see the question number 15. Let us read the question number 15. What mass of calcium will contain the same number of atoms as are present in 3 gram of sulfur? That means first you have to find out the 3 grams of sulfur, how much atoms are there. 3.2 grams of sulfur, how many atoms are there. Then you have to compare with the calcium. And it has come in the 2015, so it sounds important. So let us see. First we will talk about the sulfur. Molecular weight of sulfur is 32. So 32 grams of sulfur weighs how many atoms are there? 6.022 into 10 to the power 23. That means they are weighing the Avogadro's number. So 1 gram will weigh into 6.022 to the 10 to the power 23 by 32 atoms. Now according to the question 3.2 grams weighs how much? This much we will do, and the answer comes out as 6.022 into 10 to the power 22 atoms. Okay, now we will come to the calcium side. Now we know that atomic weight of the calcium is 40, Ca is 40 grams. So 40 grams of calcium weighs how much? Same. That is the Avogadro's numbers of atoms. That is the 6.022 into 10 to the power 23 atoms. Now we will see, according to the question, the mass of calcium contains the same number of atoms as are present in 40 grams of calcium. The question says that because they contain the same number of atoms, so we will write it. So since mass of calcium contains the same number of atoms means calcium also 6.022 there and sulfur also, then atoms as are present in how much? 40 grams of calcium. So since they are containing the same number, so how much of the calcium has come out? Sulfur has come out 6.022 into 10 to the power 22. Okay, so we will see that. So is equal to will be how much? 40 into this much, 40 into 6.022 into 10 to the power 23. That is for the calcium, and divided by of the sulfur is the 6.022 into 10 to the power 22. So you make it divide. After division it comes out, because this 2 will get divided. Okay, this 2 will be cut, 10 will come, 10 fours are, so 4 grams. Okay, So in this way we find out how much the mass will be the same. It comes out as a 4 grams. Now coming to the question number 16. 16 has 3 breakup questions. That is, calculate the number of atoms. Number of atoms you have to find out of the following: 52 moles of helium, 52 AMU of helium, and 52 gram of helium. Let us see now one by one. Now we know that atomic mass of helium is 4 grams. Okay, helium is the 2 and the 2 of the neutron, 4 grams. So 1 mole is equal to how much? Oh, it should be 6.022 into 10 to the power 23. So 52 moles will contain how much? 52 into 6.022 into 10 to the power 23. So answer will come out. Now coming to the number B. 52 AMU, atomic mass unit of helium. 52 AMU of helium. Now we know that 4 grams of helium means what? 1 atom. Okay, because in terms of AMU, atomic mass unit, we have to take out. So 1 will be how much? 1 by 4. And how much given? 52. So 52 will be into 52. So answer will be how much? You make it 13 AMU. Okay students, it comes out to 13 AMU. Or you can say 13 atoms. Okay, don't say AMU because AMU is given there. Atoms. Clear? It is not possible to solve all the sums. So I have given you in the PDF. You just try to solve from there. If you find any problem, then write to me. Now question number 20 says, what is the mass of 56 centimeter cube of carbon monoxide at STP? That means they are talking about the gas at STP. Let's see. So molar volume. Now molar volume will come. So molar volume is what? That is the volume occupied by 1 mole of a gas at STP. That means volume occupied by 1 mole of a gas at STP. Okay, so now 1 mole of CO. CO means you have to take out the molecular mass of CO. C is equal to 12, O is equal to 16. So 1 mole of CO is equal to how much? 16 plus that means 28. You can give the grams. Okay. Now we will come that to the, since it is in grams, so you have to make it change that one. 22.4 we cannot take. 22400 we have to take. We have to bring it into the centimeter cube. So 22400 cm cube of the carbon monoxide gas will give how much? Actually, how much is there? 28 grams, 1 mole of it. Okay, it occupies that much. So 1 will occupy how much? 28 by 22400. And how much given in the question? It is given there 56. So since it is in 56 centimeter cube of carbon monoxide gas will occupy 28 by 22400 into 56. Now you calculate it. 0.07 gram. Okay, clear? Now in this way we have almost covered up maximum of the sums, but one little bit sum is there which is little bit. Now you try to solve from 21 onwards. I am not doing anything from here. You try to solve it, and if you cannot, if you find any difficulty, I have given you the solution. You can go through them also. I am doing the last sum for you, not the last, second last sum. Number of molecules in 4.2 grams of ammonia. Let us see how we will find out. One sum I am doing from here, from the last, and rest of the sum you try to practice. Solution has been provided to you. Just have a look. Now question number 30 is the number of molecules in 4.2 grams of ammonia. So ammonia is how much? Molecular mass of ammonia. First you have to find. To 17 grams. 14 plus 3. Now what is being told here? That number of molecules. Okay, so we know that 17 grams of ammonia contains number of molecules told, so 6.022 into 10 to the power 23 molecules. Okay, now 1 gram of, so 1 will be how much, this will be how much. Okay, how much value is given? Molecules, then 1 will be containing 6.022 into 10 to the power 23 divided by 17, and how much given in the question is 4.25. So 4.25 grams of ammonia will contain 6.022 into 10 to the power 23 divided by 17 into 4.25. This is equal to, you will just do the calculation, it will come out to be, I am directly writing the answer, you will calculate it, 1.5 into 1.5 into 10 to the power 23. Okay, molecules, it will come out. So in this way I have done the second last sums for you. Now you see this answer will match with the which answer, which is the correct answer. You see number B. B is the correct answer for it. So answer is B. Okay students, so keep practicing all this. Stay healthy. Have a nice day. Thank you.